Hi, folks. Welcome back to Physics with Captain Rod. I'm making this video here to discuss just some common geometries that show up in physics and other areas for that matter. So the first one we're going to talk about right here is just the circle. So effectively, this is just a two-dimensional type of geometry. And a circle, has a certain diameter and it has a certain radius. And that radius is half the diameter. And two important things about the circle are this. One, very common to need to know how to calculate the circumference, which is the distance around. And that circumference can be calculated by taking 2 pi times the radius, where pi, is 3.14159, yada, yada, yada. Another common thing to have to calculate for circles is the surface area here. This area right here. And the area of a circle is pi r squared. Pi times the radius of the circle squared. Okay, next common geometry here. A sphere. That's this animal right here. And a sphere, again, has a certain radius. And there's a couple important quantities that you typically might have to calculate with a sphere. One is the volume of a sphere. The volume of a sphere is 4/3 pi times the radius cubed. And another important one to calculate is the surface area. The surface area of a sphere is 4 pi times the radius squared. And that would tell you, again, the surface area of that three-dimensional shape, meaning basically how much paint would it take to paint it kind of calculation. All right, another common geometry here, this one. I would just call that a disk. The disk has a certain radius and a thickness. Now, what we call this thickness, this is up to us. I'll just put T for thickness, if that's okay. Some common calculations here. Well, let's talk about the area of just the top of it. Just the top would have an area of pi r squared because it's a circle. The bottom of that also would have an area of pi r squared. Now, if we needed the entire surface area, we would need to add them together. I'll put area total. We would take a pi r squared for the top, another pi r squared for the bottom. Then there's also this little tiny area around it. Now, it's typically, in a geometry like this, it's small compared to the other two, but if we needed it, you could calculate that by taking 2 pi r times the thickness. Now, the reason that works, the 2 pi r is the circumference, remember? That would be like this distance around. And then when we multiply by the thickness, we're getting the area here of that little side surface. Another important geometric factor, the volume of this thing. Well, if we take the surface area right here, pi r squared, and we multiply by the thickness, we now have the volume of this object. All right, the next one I'm going to talk about here, this animal, is the cylinder. Now, really, for all practical purposes, the cylinder and what I call the disk are the same. They're the same thing. Just I will treat them like they're a separate object, but surface area, total surface area of this object is 2 times pi r squared. That gets this and the one on the other side, plus, we call this like length. 2 pi r times the length gets the surface area of the side of this thing, this stuff. Now that's formula-wise, whoops, it's the same as this. Right? The only difference is here, because it felt more appropriate, I called this a length instead of a thickness. And then volume, if we take pi r squared and multiply by the length, right? We would get the volume. So there's kind of an overview of the some important geometries that show up in physics quite often. And let me point some things out. Circumference is a distance, right? It's a one-dimensional thing. So any formula you use for a distance should have units of meters. Any formula that you use for an area should always have units of square meters. And any formula that you use for volume should have units of cubic meters. So as you look through these equations, make sure that it's, it should be perfectly clear if I pick one, this one. Okay, r squared has units of square meters. So it has to be an area, even if you don't realize what it's labeled as. And this one has to be a volume because, again, that has units of cubic meters. And again, this one also has to be an area because if you look at these terms, if you look at this product and this product, these have to have units of square meters. So understanding how the units work out for length, area, and volume will help you decide which formulas you use when in doubt. But anyway, I hope that this video helps. Have a great day.